2022 से भी जाना है ये, इस साल गया, इस साल जाना था, चला गया होगा मार्स पे। हो चुका 2000 का
आज से थोड़ी दिन पहले हुआ।
आज रीड के हो चुका कि होने वाला है?
તમે આની પેલી નથી લાયા હેડફોન લાવવાનું રહી ગયું હા છે હા અવાજ ઓછો
We request all the participants to kindly mute themselves.
Good afternoon to one and all. Let me welcome you all to the 10th webinar of the Robotics series. Today we have amongst us Ms. Surbhi Bhagotia to talk about NASA's Mars 2020 mission. Ma'am was passionate about space since childhood. After her schooling of various colleges in Delhi, she pursued graduation in aerospace engineering from Indian Institute of Space and Technology, the premier institute of space research organization. During her college days, she participated in the Sounding Rocket project, which was the first sounding rocket built by Indian students. Upon graduation, she joined the Vikram Sarabhai Space Center of ISRO. Her field work involves the design and development of various mechanisms for ISRO's programs. Currently, she is developing mechanisms and systems for the Gaganyaan program, which will fly the first Indian to space. We are extremely honored to have you amongst us, ma'am.
Thank you, Avni.
Now, I would like to welcome on board the lady with the vision, the lady who started the legacy of the robotics to equip the kids with the brain development mechanisms, the lady who is an inspiration to many, who is the heart and soul of all our webinars, Mrs. Dimple Verma on the board. I would like to give my heartfelt gratitude to Dimple ma'am for giving me this opportunity to moderate and learn from some of the dynamic brains of the country. Dimple ma'am, we would like a few words from you.
Thank you, Avni. Hello, everyone, and welcome back to our series of webinars for young minds. I'm Dimple Verma, heading WHIZROBO, Institute of Robotics, Science and Technology. I'm into STEM and robotics education for K-12 students, where we prepare future-ready children. This is our 10th webinar, where we are trying to come up with latest emerging topics, engaging our tech enthusiasts with latest updates around the globe. And today's hot topic is NASA's Mars mission 2020. Humans did not evolve to go into space, but we go there anyway. And that led to the development of various technologies that feed back into the economy, improve our lives on Earth. Without these space programs, we would not have GPS, accurate weather predictions, solar cells, or the ultraviolet filters in our sunglasses and cameras. To my surprise, there's also a medical research happening right now that could cure diseases and prolong human lives. And these experiments cannot be done on Earth. Space exploration is helping us, making our lives easier. Let's welcome our special guest, Ms. Surbhi Bhagotia, scientist at ISRO, who has been kind enough to take out her precious time to give us insights about NASA's Mars mission 2020. We all are excited to hear and gain knowledge from her. Over to Avni.
Thank you so much, ma'am. This is for the information of the audience that the chat section will be open to questions throughout, and they will be addressed later on. It will be appreciated if the questions which are left could be dropped in a mail so we can get back to you with it. Over to you now, Surbhi ma'am.
Thank you, Avni. Thank you, Dimple ma'am. Good afternoon, everyone. Today's topic is NASA's Mars 2020 mission. And it is very important and relevant because this is going to be launched next week on 30th of July. So let us look at what will be the outline of the presentation. I'll be talking a little bit about Mars, then about the Mars exploration program of NASA, then the mission that we are talking about, Mars 2020 mission, the rover and the helicopter that are going in this mission, Perseverance and Ingenuity, and then we will talk about the ultimate future. So basically, who observed Mars? Humans have been observing Mars since at least 4,000 years, because that is when the first documented evidence we have got of some Egyptian astronomers looking at Mars. And it was easy because it was bright and close to Earth. But Galileo Galilei was the first person to observe Mars using a telescope in 1610. So why is Mars interesting? Mars is there in something called the Goldilocks zone, where even Earth is there, and it is a habitable zone. It is an area around a star where it is not too hot or not too cold for liquid water to exist on the surface. So why is it called the Goldilocks zone? If you see the photograph on the left side, there was a little girl with golden hair, and she went out into a cottage of 3 bears. There she found out 3 bowls. One was a big bowl with porridge which was very hot. Another bowl was with porridge which was very cold. And she found the third bowl, which had porridge just the right temperature to eat. So like that, a habitable zone, if we have a planet which is very near to its sun or star, it will be becoming very hot. So water will just evaporate and boil. If it's too far away from its star, the water will convert into ice. And if it's just the right distance, then water can exist in its liquid form on the surface. So like Earth, there are many other planets which fall in this habitable zone. As you can see, our sun is where 6000 is written. 6000 Kelvin is the surface temperature on sun. And we can see Earth and Mars on the conservative habitable zone in this graph. And there are other planets which also belong to different types of suns and in their habitable zone.
कोमल को आवाज दीजिए.
So recently, in January 2020, NASA's Transiting Exoplanet Survey satellite discovered the first Earth-sized planet in its star's habitable zone. And this planet is called TOI 700d. This is the star in the center, and there are some 3 planets revolving around it: TOI 700d, 700c, and 700d. And only 700d is the one which falls in the habitable zone. So there is possibility of life there. And in April 2020, from the Kepler Space Telescope data, Kepler 1649c planet was also found, which is some 300 light years away from Earth, and it is similar to Earth in size and estimated temperature. So there is a possibility of life. Coming to the NASA's Mars exploration program, it is a long-term effort to explore the planet Mars, and it was formed in 1993 with the following objectives. First, to determine the signs of life on Mars, to understand how life came to Earth also, and then characterize Mars climate. As you know, Mars climate is a bit different than Earth. It is mostly governed by the polar ice caps and the dust storms that happen on Mars, as well as the water vapor which gets exchanged from the atmosphere to the surface. Then the third objective was to characterize the geology of Mars. So as compared to Earth, there is a different geology on Mars. First of all, there are very huge volcanoes on Mars. And second thing is that there are no tectonic plates or the crust which shifts on Earth. That does not happen on Mars. Then the last objective is to prepare for human exploration of Mars. So in the NASA's Mars exploration programs, there have been 8 missions starting from 1996, the Mars Global Surveyor mission, and then 1998, 2001, and then Mars 2020 will be the 9th mission. If you see all these missions, there is approximately a 2-year gap between every mission: 2001, 2003, 2003, 2005, 2005, 2007. So what happens every 2 years? Why every 2 years a mission is being sent by NASA? So there is something called a launch window. Consider the figure on your right-hand side. So this blue dot, if you see, is Earth. The green dot is Mars, and the pink dot is the spacecraft that we are sending from Earth to Mars. So there is a particular time every 2 years where the Earth and Mars will be in such a position in their orbits that if we launch any spacecraft from Earth, it will be reaching Mars with the least amount of energy or least amount of fuel required. So that is why if you see in the left-hand side graph, there have been every 2 years, 2012, 2014, 2016, every 2 years, somebody or the other is sending spacecrafts to Mars. And here we have the distance between Earth and Mars in gigameters, that is 10⁹ meters. So if we see 2014, there is one orange triangle and one gray triangle. Orange triangle is the MAVEN mission of NASA, and the gray triangle is our own Mars orbiter mission, which was sent in 2014. And this year, in 2020, we have these 3 triangles. So there are 3 missions which are being sent to Mars. First is the Tianwen-1, which is a Chinese mission. then the blue one, which is the Mars 2020, and the red one, which is the Emirates Mars mission, that is United Arab Emirates, UAE mission. So this year we have the launch window from mid-July to mid-August. If we send any spacecraft to Mars during this period, it is very high probability that we will be able to correctly land on Mars with the minimum energy. So again, this is another picture which is depicting the same thing. If you consider the position of Earth during launch this point and Mars during launch this point, then when the spacecraft goes into the orbit, Earth will have reached over here because Earth is revolving faster, and Mars on an outer orbit is a little slow and it will reach up to here, and the spacecraft will be easily able to reach to Mars. So there is a small video which will tell us what happens every 2 years.
How do you get to Mars? If you want to send a spacecraft all the way to Mars, first you'll need a fast rocket to escape the pull of Earth's gravity. The heavier your spacecraft, the more powerful your rocket needs to be to lift off. Next, make sure you launch at the right time. Mars and Earth orbit the Sun at different speeds and distances. Sometimes really far apart, and other times they come closer together. About every 2 years, the two planets are in perfect positions to get to Mars with the least amount of rocket fuel. That's important. The total trip is over 300 million miles. Finally, make sure your aim is right. You can't shoot for where Mars is at launch time. You have to aim for where it will be when you get there. It's a lot like how a quarterback passes a football. Also, you may need a few thrusts to correct your direction along the way so you don't miss Mars. If all goes well, you'll get to the red planet in about 7 or 8 months. Then, if you actually want to land on Mars, well, that's a whole other challenge.
Okay, so coming to the ISRO's own Mars orbiter mission, which was launched on 5th November 2013. It is also called the Mangalyaan, and it was launched by ISRO, Indian Space Research Organization. It is India's first interplanetary mission, and it made it the 4th space agency to reach Mars after Roscosmos, which is Russian space agency, NASA, USA's, and the European Space Agency. So we became 4th then, and it also made India the first Asian nation to reach a Martian orbit and the first nation in the world to do so in the first attempt or the maiden attempt. So we have been orbiting Mars using Mangalyaan since 24th September 2014, and it's still working. So some of the very beautiful pictures that Mangalyaan has given us is this global shot of Mars, where you can see on the northern pole, there is the ice cap. And then you can see the 3 linked craters of Mars. They are 3 linked together. And then we have Olympus Mons, a large volcano on the planet of, on the Mars planet. And we have another photo, which was recently shot, that is on 1st of July. Mangalyaan shot this photo of one of the moons of Mars, Phobos, and it was shot using the Mars color camera, which is there in the Mangalyaan. So what were the other launches that happened in 2020? Actually, on 19th of July this month, United Arab Emirates, UAE, had launched a Mars mission, which has an orbiter named as Hope, and it will study daily and seasonal weather cycles, weather events in the lower atmosphere, such as dust storms, and how the weather varies in different regions of Mars. And it was launched from Japan by a Japanese rocket. Coming to the Chinese mission, China Mars mission happened just 2 days back on 23rd July 2020. So Tianwen-1 is the spacecraft which has an orbiter, a lander, and even a rover that can travel on the surface of Mars. It will search for evidence of both current and past life and assess the planet's atmosphere or environment. It was launched from China on the Long March 5 heavy lift rocket. Coming to the mission of our focus, Mars 2020, it's a Mars rover mission by NASA, and its launch is planned on 30th July. That is next week at 5:20 p.m. Indian Standard Time. So what are the objectives? First is to seek signs of habitable conditions on Mars. That is, identify subsurface water. So the goal here is, on Earth, we know that life exists where water exists. So on Mars, we are also following water, or wherever we have possibility of finding water, we believe that we will be able to find life there first. Then the second objective is search biosignatures for past microbial life. Now, life like humans, it is very difficult. And I think we would have known if people like humans or aliens had existed on Mars. So we are looking for microbial life, which are small single-celled microbes. And then the third is to collect and package samples of rock cores and surface soils. This is something which we can collect and bring back. And then we have technology demonstrations for humans expeditions on Mars. For example, a very important thing for humans to be able to survive on Mars is pure oxygen, availability of pure oxygen. So there is one experiment which is being done on Mars with this mission, where the Martian carbon dioxide, which Mars has in abundance, will be converted to pure oxygen. And we will also characterize weather, dust, and potential environmental conditions which could affect future astronauts living and working on Mars. Then the last objective is improve the landing techniques, because landing is a very challenging task on any planet. So let us see the rocket which will take this Perseverance rover and Ingenuity helicopter to Mars. So it is called the Atlas V rocket. As you can see, this is the payload fairing. Payload is also, spacecraft is also known as payload, and it is protected. When it is being launched, it is protected from the heat generated in the atmosphere and the high amount of sound that is generated when we are going at very high speeds through the atmosphere using this payload fairing. So it is in two halves. It will be protecting the spacecraft, and once we are out of the atmosphere of Earth, this will be separated and released. So this, in the lower picture, you can see it is in like encapsulated, and the spacecraft is there inside. And then it is lifted and assembled to the top of the rocket. So that top of the rocket is where our spacecraft is sitting. Okay. And Atlas V rocket is there at Cape Canaveral Air Force Station in Florida, USA. So let's look at the landing site. Where is this going to land? In this figure at the top right corner, you are able to see all the missions which have landed on Mars. If you remember Phoenix, it is there near to the North Pole. Then we have the Spirit here and the Opportunity here. Then the Mars 2020 rover will be landing somewhere here. So its entry, descent, and landing will happen next year on February 18th. And this kind of entry, descent, and landing will use a new technique called the terrain relative navigation. That means you're observing, when you are going down, you're observing the surface of Mars and trying to find out a good place to land. Not something very rocky or hilly terrain, but a simple leveled area. So if suppose this descent stage is able to see that there is some kind of rocky land over here, it can even divert the rover and it will land somewhere away. So this is very important. And the landing site that this time we are saying is the Jezero crater. This right bottom image you can see is the Jezero crater. And here you can see little river type of thing coming. And this is the crater where maybe a lake existed earlier. And this is the delta region where a river, if you remember, Brahmaputra has a big delta, and when it reaches Bay of Bengal, same way, this river would have entered to this lake through this delta area. And this is a very important place for looking for life. So I will quickly go through the three sites which were selected for landing. And out of that, one is the Jezero crater, which was finalized. First is the Columbia Hills, as you can see here. This is also the site where the Spirit rover had gone, and it has already found little evidence of water and suggested that the crater may have first hosted a shallow lake. Then we have second, this Jezero crater, and you can see the delta is clearly visible, how the river is getting distributed to different streams and then entering into the lake. So this is a very highly interesting area. And here it was an ancient lake bed, and microbial life could have developed here. The river delta structure suggests that water filled and drained from the site at least 2 times. So maybe it got dried up and then it got filled again and then dried up. So at least 2 times it was filled. Then we have the third area called the Northeast Syrtis. It is an ancient volcano, and this site could have led to hot springs and melting ice. So these are ideal conditions for past microbial life. However, out of these 3, only one could be selected, and they have selected the Jezero crater. And this landing site offers geologically rich terrain because, near to the delta region, the land is very fertile, and with landforms reaching as far back as 3.6 billion years old, that could potentially answer important questions in planetary evolution and astrobiology. Getting samples from this unique area will revolutionize how we think about Mars and its ability to harbor life. So we have one video about the entry, descent, and landing.
How do you land on Mars? Very carefully. Your spacecraft hurtles toward the planet at thousands of miles per hour, so you'll have to hit the brakes in a hurry. First, your capsule needs a heat shield. It protects the spacecraft inside from the heat and friction of entry into the atmosphere. Friction slows you down over 90%, but not enough to land safely. Use a parachute to slow down even more. Still, falling at over 100 miles per hour, you need the right system to land safely. Here are some options. With a small to mid-size rover, use a cushion of airbags along with retro rockets. Impact at 30 miles an hour and bounce to a stop. With a large lander, use retro rockets and landing legs to touch down, going about 6 miles an hour. Or with a large heavy rover, use a big jetpack to slow down to under 2 miles an hour. Then gently lower it on cables to land on its wheels. Any way you do it, you'll need skill and hard work. There's nothing easy about landing on Mars.
Okay, so coming to the Perseverance rover, as you can see, it has the main job of seeking signs of ancient life and collect rock and soil samples for possible return to Earth. So the launch window, that is the time if we launch between July 30th and August 15, we will be able to reach Mars on the February of next year. So the landing will be on February 18th. The duration will be at least 1 Mars year, which is equal to 687 Earth days, more than 2 years. So almost 2 years. And then the length, width, and height of this rover, you can see, is much more than like a 7 feet tall person. And its weight is 1025 kilograms, which is 1.025 tons. So it is a very heavy rover. And the bottom and the sides are the frame of a chassis. If you compare it with a car has a chassis or a platform. So bottom and sides are the frame. And top of the rover is the equipment deck where all the things will be kept. And it has one new sampling and caching interior workspace. So whatever samples are collected from Mars will be kept in that area. Let's look at some of the instruments that are there on this rover. There are 7 instruments on this rover. Starting from the top, we can see there is Mastcam Z, which is a zoomable panoramic camera. It is like an eye of the rover. And it will give panoramic and stereoscopic imaging where we can zoom in and zoom out. And it will determine the minerals on the Martian surface. It will also assist in rover operations. Going anti-clockwise, we have RIMFAX, which is a radar imager for subsurface experiment. And it has a ground penetrating radar, which will give centimeter scale resolution of the geologic structure of the subsurface. Then we have a very interesting instrument called the MOXIE, which produces oxygen from the Martian carbon dioxide, and it will be very useful for future human missions. Then we have pixel. If you see, this is called the robotic arm. I'm sure most of you are working on robotics, and in these kind of rovers, we are using something called a robotic arm, which has 5 or 6 degrees of freedom. This one has 5 degrees of freedom, like our shoulder. It has an elbow joint, and then it will have a wrist joint and something for the fingers. So, so the planetary pixel, it has one of the instruments called planetary instrument for X-ray lithochemistry, which is an X-ray spectrometer, and it will image high resolution to determine the fine scale elemental composition of Martian surface materials. It will give more detailed detection and analysis of chemical elements than ever done before. Then we have something called Sherlock and its good friend Watson. So it is scanning habitable environments with Raman and luminescence for organics and chemicals. It is a UV laser basically to determine fine scale mineralogy and detect organic compounds on Mars. So it is the first time a UV Raman spectrometer is going to fly to Mars surface. It has a high resolution color camera for microscopic imaging of Mars surface. That camera is called Watson. Then in the center, we have MEDA, which is a weather station. It is the Mars Environment Dynamics Analyzer, which will measure the temperature, the wind speed and direction, pressure, relative humidity, dust size and shape. And in the end, at the top, we have SuperCam, which is a laser micro imager, which will provide imaging, chemical composition analysis, and mineralogy. It will detect the presence of organic compounds in rocks and regolith from a distance. It can do that from a distance of about 12 meters also, so far away. So what does this robotic arm that you see in the blue circle, what does it do? Basically, at the end of this robotic arm, we have something called a turret, which rotates, and we can use different tools in that. So what are the different tools on the turret? The Sherlock and Watson that I have already told, Pixel, I have already told. Then the gaseous dust removal tool. I will tell why this is important. Then there is one ground contact sensor. So suppose this arm goes and hits the surface of Mars. It has to be protected. So this sensor will tell us that it has touched the ground, and it will protect the arm and bring it back again if it senses that the arm has touched the ground. So it prevents any kind of damage to the robotic arm. And then we have a drill. So consider it like a geologist who is going on the surface of Mars. Since we are not sending humans, we are sending such rovers which should function like humans and try to understand what is there on the surface of Mars. So first, any geologist will go and identify a promising target or a good rock to study. So the mast cam or the super cam that is there on top will actually identify the target. Then the rover will move close to the target and take a closer look. Like suppose it is a geologist uses a hand lens. Same way, Sherlock and Pixel will be able to zoom in and go very close to that rock and see if it is interesting. Then rover will use something called an aberrating drill. So it will chip off the rocky surface and it will create a circular spot on the target rock. Because anytime you are doing any kind of surface investigation, you will try to remove all the dirt and try to get into the actual rock that you want to look at. So this abrading tool will help for that. And when that abrading process is done, there will be lots of chips and powders after the abrading. And this gaseous dust removal tool will shoot puffs of ultra pure nitrogen to clear this dust and debris generated during the abrading process. So then this rock will be available for studying, and Pixel and Sherlock will do a close-up inspection with help of Watson camera, which is similar to a geologist's hand lens. And this figure shows how people in NASA, engineers in NASA are attaching everything on this arm. Now, one of the very important things that we are doing with this mission, NASA is doing with this mission, is listening to Mars. Till now, we have used all the 4 senses: the sight, where we could picture Mars; the hands and the arms and the feet have even been used to touch Mars; And chemical and mineral sensors have been used to taste and smell Mars by knowing the kind of minerals that are there, organic compounds that are there. But it will be the first time that we will be hearing what is happening at Mars, or the sounds of Mars. So we will be using the last of our 5 senses that we have to exercise on the red planet. And when the Perseverance rover arrives at Mars, it will have 2 microphones. You can see these 2 blue circles. One microphone will be here near the supercam, and one will be on here side. And finally, we will be able to hear the sound on Mars. And why it's the first time? Because unfortunately, when previous missions, the microphone was sent, one of the missions failed, and the other mission, this instrument was never turned on. So that's why it's the first time we are going to listen to Mars. Coming to the anatomy of the rover, or the body of the rover, we have these, if you compare it with the car, we have these wheels at the bottom, which are made up of aluminium, and which have these cleats or protrusions, which are good for traction or giving friction with the surface and rotate. And if you see, this size of this wheel is about 52 centimeter, which is quite a big size. And that's why with a 1 full turn of this wheel, the rover will be able to move more than 1 meter by 1 full turn. And then there is a suspension system that we have like in our cars. It is called the rocker bogie suspension system, which I know is important for all the people who are doing robotics. Then differential, which is helping the rover to move from left to right turn. And this robotic arm, the shoulder 2 degrees, one in the elbow, wrist, and the turret. So let's look at the suspension system. Why a rocker bogie suspension system is used is that it will help the rover to climb through obstacles. So if you see, if a rover is finding an obstacle in front of it or a rock, its first wheel will climb. Then when it moves further, the second wheel will catch up. And then when it moves further, the third one. So this is how a rocker bogie suspension system helps. So let's look at one of the videos of this rover.
NASA's next Mars rover is in development and has an ambitious mission. Decades of Mars research from previous spacecraft have shown the planet not only had water in the ancient past, but had environments that could have supported life.
Mars is our neighboring planet and in many ways the most similar to us, and certainly in its history. And the question whether ancient life was there is still the question that keeps us up at night.
Mars 2020 has 2 new objectives: to specifically seek the signs of life and then sample materials and prepare a cache that could be returned to Earth by a future mission.
Mars 2020 is really the essential first part of a sample return mission. So it actually looks at the environment of these samples and then collects them and stores them. Afterwards, we will of course go and bring these samples back. So Mars 2020 is the first half of a return trip.
The Mars 2020 mission, to the maximum extent possible, follows the Mars Science Laboratory Curiosity mission. We're going to use very similar rocket, very similar cruise stage, very similar entry, descent, and landing. And the rover, when you step back, will look almost identical.
Not only were a lot of designs already developed for the most part, but we're also using a lot of spare hardware that we had from MSL or Curiosity for Mars 2020. If you know where to look on lab, you can walk around and see a lot of the EDL hardware and the cruise stage hardware that's already been built.
And this is really important for understanding why this mission makes sense. We have to do relatively little in the way of new development. And this saves money, it saves risk, it saves time. It's the right way to pursue this kind of mission.
Mars 2020 also features new technologies for entry, descent, and landing, allowing it to target a smaller landing zone and even divert from known risks in the area.
It means that we can both go to places that are maybe more interesting to the scientists because we're able to handle places with more hazards, as well as land closer to the things that they're interested in off the bat. So we get to the science that they care about and more quickly.
The 3 key sites that we are considering right now share one thing in common. They are all environments that might have been habitable in the very distant past. One of them is the floor of an ancient lake. another is a hot spring, and the third one is a site where hot water interacted with rocks in the shallow subsurface. We have instruments on board which are expressly designed to seek evidence of ancient life, what we call biosignatures, and we have the capability to prepare samples, drill them out of a rock, seal them in a tube so that a future mission could go and bring them up. We call that caching.
So it is a first of a new type of mission, which is to bring samples back to the best labs we have, which are here on Earth. Mars 2020 is a pivotal mission in our search for life that could finally answer the age-old question, are we alone?
Now let's come back. One thing I would like to point out, everybody in that video told that it is only first half of the mission. That means whatever samples are collected are not going to come back in this mission. There will be another mission sent through European Space Agency, and they will bring back the samples to Earth for further studies. Coming to the Ingenuity helicopter drone. So it is a technology demonstration. That means it is the first time we are sending any kind of such helicopter on another planet. And we want to first see whether this technology is safe to fly. And it will be providing better mapping and guidance that would give future mission controllers more information to help with travel routes, planning, and hazard avoidance, as well as identifying points of interest for the rover. So it will be like a buddy to the rover. It will be flying just ahead of the rover, trying to find out good and nice places where the rover can go. The whole process will be much faster because of this drone. So the advantages, it is a useful way to explore. Flying vehicles travel faster than ground-based rovers and can reach areas that are inaccessible to wheeled vehicles. Its power source is solar panels that charge the lithium-ion batteries. And it has counter-rotating coaxial rotors. So if you have seen a helicopter, there is a rotor on the top. And if you see in this photograph, there are two rotors, that is one on the top and then below that. So these two are rotating in two different directions. And that is the configuration that was used for this rover. And if you see the span, that is the length of one of the blades, it is 1.1 meter. And this whole drone weighs about 1.8 kg, which is very less already. And it can have revolutions, about 2,400 revolutions per minute. So it spins very fast. Its flight time is up to 90 seconds. That is only 1.5 minutes it can fly at one time. And then it will come back to the ground. Its operation time is 1 or more flights within the first 30 days. And its maximum range is 300 meters. So if any of you have run 100 or 200 meter races, you know how far 300 meters is. And that is how far this drone will be able to go in one go. And it has a maximum altitude of 5 meters above the surface it can fly. And maximum speeds are horizontal speed of 10 meters per second and vertical speed up and down of 3 meters per second. Coming to the anatomy or the body of the helicopter drone, we have antennas at the top, which helps us to communicate, or helps this drone to communicate with Earth using the link. Like it directly cannot communicate to Earth. It has to send a communication to the rover will send to the orbiter, and then the orbiter will send to Earth. Then it has these blades that I talked about. They are black in color and made up of carbon fiber foam, which provides lift in the thin Mars atmosphere. And these are very lightweight blades. Then we have the batteries that help power the helicopter, which are kept in the central cube region. Then we have the legs, which are also ultralight and also made of carbon fiber tubes, which help to land after each flight. Then we have sensors and cameras in the center, and it collects data on how fast the helicopter is traveling and in which direction it is going. And basically it's the eye of the helicopter. And then we have the avionics, or aviation electronics, and the body. So it is the brain of the helicopter, and it helps the helicopter function and navigate. Like we use Google Maps here on Earth, this will be using its brain, or the avionics kept in the center, to navigate. The body has insulation and heaters to keep the sensitive electronics warm, because Mars has very cold nights. So all these electronics have to be protected. Then solar panels are there at the top. Solar panel helps to keep the battery charged. So we have another video of the drone. So there were some challenges that they had faced, NASA had faced during the design of this rover. One of the biggest challenge was how to generate enough lift to be able to lift the helicopter up, because Mars has a very thin atmosphere. It has the density, only 1% the density of Earth's atmosphere. So that is very, very thin atmosphere. And, to generate the lift on any kind of surface, first of all, there is an aerodynamic profile given on this rotor, and then pressure will be, differential pressure will be acting so that there is an upward push which will lift this. So it was very difficult to do it for Martian atmosphere, which is very thin. And that's why the rotor is rotating very fast. That is 2,800 revolutions per minute. As compared to a similar thing, it will require on Earth, it will require only 500 revolutions per minute. And its weight is kept to absolute minimum. Even this 1 meter long blade is weighing only 56 grams, which is less than 1 kg. So that is the kind of difficulty they had faced, and they had tested it in some chamber which had simulated all the gases that are there on Mars, like 95% carbon dioxide, 2.5% nitrogen, 2% argon, fraction of O2, so oxygen. So that is how they had done the testing. And this is Bob Balram. He is of Indian origin, and he is the chief engineer for this helicopter in Jet Propulsion Laboratory, NASA. Some of the other challenges were low gravity. Mars gravity is only 1/3 of the gravity of Earth. Then a lot of radiation. So, when we have certain power in this helicopter, only 1/3 of that power is used for actually lifting the helicopter. Rest of the 2/3 of the power is used for keeping the electronics warm. So you can say that 2/3 of its power is being kind of wasted, because the temperatures have to be maintained, and that's why we are able to use only very less power, and that's why it has such less time of flight, because we have to keep it charged. So coming to the ultimate future, I think by 2030s, people are claiming that there will be human missions to Mars. And you can see there can be different kinds of settlement on the Mars surface. There can be even a colony on the surface of Mars. There can be underground colony where they are even having vegetation for growing food. And then there can be people exploring the surface of Mars under wearing certain suits. And there are instruments and experiments that can be done. And I just wanted to show at this point, like we see Mars as a small red dot in the sky when we see it from Earth. And this is how Earth looks like when we see it from Mars. And one of the rovers has captured this picture where Earth and Moon are also visible. So Earth is also like a small dot in the sky for Mars. So you can see how far we are from Mars. And in the end, I would like to just say that nothing in life is to be feared. It is only to be understood. Now is the time to understand more so that we may fear less. And that was said by Marie Curie. Thank you. And I think I'm ready for any questions that you might be having.
Thank you so much, Surbhi ma'am. It was really a power-packed session, you know, a lot of insights. And actually, I was thinking there are a lot many things which I think we are never able to think about the creations or the innovations that's been happening, you know, at the back. I mean, we are never even able to, but you have, you know, shown it in such a beautiful way. And believe me, it was so excited to see all these things happening. And thank you so much. I think all our children, they must be excited to see. So is there anything that, you know, we can see this actually, how they are gonna, will they make it live for people to see about all these things?
I think so. Certain things they might make it live. So we have to just follow. So whatever information I have given in this presentation is all available on the internet. And if you follow NASA's site, you will find details about what all they are streaming live and everything. Even we'll have to check that out, and we'll have to keep following. First we have to follow the launch on 30th of July. That is next week. And then from there it will take some 6 to 7 months to go there, and in February when it is about to land and all that, they might also show that. So we have to keep a track of that.
Okay, thank you so much. Yes, Avni, so let's take some questions from our audience.
Yes, ma'am. Thank you so much, Surbhi ma'am. That was indeed extremely insightful and informative. Thank you so much for sharing that with us.
It's my pleasure. Thank you.
So, ma'am, the first question is that how would the rover divert?
Okay, so let me share my screen again. I'll show you something. So what happens? So basically the capability, since it's a heavyweight rover, what will happen is it will be having a descent stage attached to the rover. So this is the rover, and there are it is attached to a descent stage which is having these thrusters on the sides using some ropes. Okay. So this descent stage we can control by changing the direction of these thrusters. So from an altitude of around 300 meters above the surface of Mars, if we see that where we are going to land is not a safe place, then this descent stage, the thrusters can be moved in such a way that it will divert the trajectory, and it will gently keep the rover on a nice place. And this is the actual, artist's impression of how it. This is the same way it happened in the previous rover mission of Curiosity. And there were some missions which was lighter rovers were there, so they had used just airbags which will bounce. But the thing is, we cannot control where it will go up to. If you bounce something, that ball will roll to some other place. So this is more precise kind of landing. And after it places the rover on the surface, these tethers or the ropes which are connecting it to the descent stage, they will get cut.
Right. Thank you so much, ma'am. So, ma'am, my next question is, why is the rover called Perseverance?
Okay, so this I understood was that there was a contest and all the rover names which are being sent by NASA are based on human, characteristics like curiosity, perseverance, spirit, opportunity. These are things that any kind of exploration requires. So I think out of some 8 or 9 suggestions, one of the names that was selected was Perseverance, which was given by one of the students in US. So I think that is the story behind the name.
All right, ma'am. Thank you so much for that. Ma'am, my next question is, how is Mars 2020 mission different from other missions?
Okay. So if you see, there are, one second. if you see the different missions of NASA, then initially they used only an orbiter and send that to Mars. So it will be only a spacecraft which will be rotating around Mars. It will not land. And then they had sent the Mars exploration rovers, Spirit and Opportunity. So these are the rovers which can travel on the surface of Mars. And Phoenix also had a lander. And so there are three things: orbiter, lander, and rover. Some missions have only orbiter, which will survey the Mars surface from a distance. So it is called remote sensing that we do for Earth also. And then we have something called a lander, which will land at a particular place and do all that, you know, experiments and sample collection and everything in that single place. And if we have a rover attached, we can also travel to certain distance and go to other places and look for better places to sample. And if we have something called the Ingenuity drone or helicopter, then we can go even further distance faster. So this time we are NASA is just going to see whether this kind of technology will actually work, that helicopter drone. And if it works and if it is proved on Mars surface, then it will be sending much more improved versions of it. So these are the kind of differences from the previous two missions to now. And this has, if you wanted to make such a lightweight helicopter, the electronics that you used 10 years ago or 20 years ago, you could not have made it because those were very heavy electronics. Even our computers and our phones are becoming smaller. So that is the only possible way we could send smaller and lighter helicopter drones to Mars. That is the difference today from yesterday or like years ago.
Thank you so much, ma'am.
Avni, we have another question in the chat box. So the question is that can't we launch a robot which is like human? If it works like human, then isn't it will be better than this?
I'm sure, like I agree, it will be much better if you have a humanoid going to Mars and doing this thing. But humanoid technology, the similar things can be done with this kind of a rover, like focusing, zooming in, trying to figure out what is a. So I think nobody has tried that right now, and I have to check out what are the plans for, if there are any such plans of sending humanoid robots to Mars. But as of now, people have just sent rovers. Yeah, I think it is an easier thing to do than humanoid robots.
Yeah, I think that is really better because, you know, instead of putting human lives into danger, it is better that first we send the rovers, and then once we get that success, once we are, you know, getting those results, what we are looking for, then maybe, you know, and I think with technology, that's not a time far wherein, you know, we all can go to Mars. So let's hope for the best.
Yeah, people have plans in 2030s. So all the young students would be the right age maybe at that time. So you can all see, or I don't know how it is going to turn out. Yeah.
Absolutely. So we are looking for these future generation children to be, you know, landing on Mars soon.
Yeah.
So we have another question, ma'am, that why did 2013 get a gap of 2 years?
Okay. Let me see. 2013. Gap of like from the previous mission or the next mission?
Yeah, I guess maybe it is related to some missions wherein, you know, there must be a gap of innovation.
So I think I explained the reason for a 2-year gap, because we are at the correct position in the orbit, and with the minimum fuel we can reach Mars if we are launched in that particular time frame. So after that, there has been a huge gap, like from 2013 to 2020. For so many years, there was no mission from NASA. So that may be because it took a lot of, it was very challenging to design something like this helicopter. As I told, it was a very challenging task. And if you get down to actually doing and overcoming these challenges, it takes a lot of time. So I think they missed in between whatever opportunities were there for going to Mars, only because the technology was not ready.
Right, definitely. So that was the time, they were taking it to develop this type of, prototype so that they can actually send it and experiment with this rover.
Yes.
So the last question is, are there any plans for making a colony of humans on Mars? I think Surbhi ma'am has already said that, yes, ma'am, would you like to comment anything on this particular part?
So if you see Mars one type of projects where there is a one-way trip to Mars and things, it has to develop slowly. Forming a colony there would also have to, we would also have to take care of the requirements of power, then communication back to Earth, food, everything to be properly done. We will even have recreational things over there like sports stadiums and movie theaters, and that is what a colony is looking for. We cannot just ask them to do some work all the time. When there are hundreds of people going there, there would be all kinds of things. So in this picture you can see it's like a small township where there are schools, there is police force, there is democracy maybe. So all kinds of things are anticipated, but there are only few companies like SpaceX which is saying that it will be able to, the only limitation is to lift that kind of each human we have to take, and then the Starship of SpaceX is something which will be able to lift a lot of weight, which is a heavy lift launcher, and they are saying that it might be able to take 100 people at a time. So if that is the case, there are certain challenges like protecting the people from radiation, because like Earth has our magnetosphere, Mars does not have such a strong magnetosphere which can protect us from the harmful UV radiation. So that's why we don't have ozone layer on Mars, and humans have to be protected from that. So if you see this underground place, if we put our habitat some 5 meters below in this soil or in the surface, then it will be giving the same kind of protection that our atmosphere on Earth is giving. So we have to maybe start with underground. So there will be a lot of drilling, boring into the surface of Mars, and that requires huge equipment. So it is a very long term plan, and many such rovers and unmanned or uncrewed missions have to be sent before a human can be sent.
Thank you, Surbhi ma'am. Thank you so much. It was, indeed a session full of informations and, a lot of insight about this Mars mission. Thanks a lot, ma'am. Over to Avni now.
Thank you so much, audience, for sparing your valuable time. Thank you so much, Surbhi ma'am, once again for sharing that with us. I'm sure this session will help you plan the best for you and your children. We would like the audience to tell us what they want for our next webinar, what they want for the next webinar to be about. So do mail us with your suggestions.